Right, this is the last example for substitution. Here I have a system of equations where one equation is in standard form, the other is in slope-intercept form. It doesn't really matter how they come, they don't have to be in the same form, but what's interesting is that we already have one variable solved for. And so I don't have to go through that first step of solving for the y, it's already done for me. So instead what we're going to do is we're going to take this expression for y and we're going to substitute it into the y in the other equation. So I'm going to write out the other equation, 3x minus 2, leave a space for that new stuff, equals 5. Again, the structure should look exactly the same, 3x minus 2, the y is our blank spot, and then equals 5. And then I'm going to replace the blank spot, or the y, with the new y, which is 1.5x plus 2. Okay. Now we're going to do a distributive property to solve this. Again, you're going to distribute the negative 2, the whole negative 2, into that parentheses. So it's 3x, negative 2 times 1.5, 1.5 times 2 is 3, so it's minus 3x. And then minus 4 is equal to 5. When I combine my like terms here, 3x minus 3x is 0x, so those actually cancel off nicely. And I'm left with the equation negative 4 equals 5. But no x's are left to solve for. So that seems kind of strange. When the x's disappear like this, you have to look at the equation that's left over. This one says negative 4 is equal to 5. Well, is that true? No, those two things are definitely different. So this is false. It's a false equation. Anytime you're left with an absolute false equation, that means the original systems, or the original equations, never actually cross. There is no point of intersection or no solution. So this is a no solution, because there is no point of intersection. This would be a situation where you have parallel lines. Okay, two lines that are running parallel. Alright, so you have parallel lines. And if you were asked to categorize this example, this would be an example of an inconsistent system with independent lines. Or independent equations. Okay, so inconsistent because they don't have a solution, and independent because they're two different equations. Okay. There's also a case, and I'm not going to do an example of this. It was related to the last example, but if you were to solve something similar and you end up with a true equation here, something like 5 equals 5 or 0 equals 0, if it's a true equation, that's another scenario where you can have an infinite number of solutions, and then you would finish that off like we did in the previous example, where you have an infinite number of solutions and you need the xy ordered pair. Okay. So again, though, this one is false, so it has no solution and it's inconsistent with independent equations.